Assalamu alaikum, chemistry students of the world. Today we're going to be talking all about esters. Now, esters are one of the biological molecules, one of the organic molecules in chemistry that we're going to be talking about. And esters are a little bit different from some of the other organic molecules in that an ester functional group is this link that links two different parts of an organic molecule. So whereas for every other molecule that we're talking about, we just have to count the carbons and see where the longest chain will tell me, its name based on that longest chain. Whereas because I've got a link in my ester between two different sides, a X and a Y side linked between this ester part, I have to count both sides and then base the name of the ester on that. So let's get into this. Hopefully by now we know a little bit about organic chemistry. We know that 1 equals meth, 2 equals eth, 3 equals prop, 4 is but, 5 is pent, 6 is hex, 7 is hept, 8 is oct, like the octopus with its 8 legs, 9 is non, and 10 is dec. And if you know your 1 to 10 in what I call chemistry language, or organic chemistry language, 1 is meth, 9 is non, 8 is oct. If I know the 1 to 10, then I'm pretty well set up for most of organic chemistry in terms of naming my different molecules. So 1 to 10, absolutely essential. And yet practice it. Think of it like another language, or 1 to 10, meth, eth, prop, but, pent, hex, hept, oct, non, dec. So 1 to 10. When I was first learning this myself, a little mnemonic that I was taught to help me remember this was monsters eat people, but prefer hairy haggis or nice dinners. For our international watchers, a hairy haggis is a type of Scottish animal. Okay, so if we know our 1 to 10, and I'm going to assume moving forward that we do, we can name our esters. Now, an ester is made of two parts. So like I said, that link in between links the two parts. And one part comes from an alcohol, and the other part comes from a carboxylic acid. So the two different parts is what makes an ester. And the name of my ester is going to be based on these two parts. It's always the alcohol part of the name that comes first. Now, it might not always be drawn that way because they could draw it the opposite way around, but I always name it based on the alcohol side. So if I have any kind of alcohol, let's take a nice simple one. One carbon, one is meth. So this is a methanol, one carbon alcohol. And I add it to, let's take a two carbon acid. So this is two carbons is eth. So this is an ethanoic acid. So I've got my alcohol and I've got my carboxylic acid. And these combined is what's going to give me my ester. So the reaction that forms an ester is called a condensation reaction. And it gets its name because I'm condensing two things into one, or two organic molecules into one. So two organic molecules, my carbon-based molecules, are condensing into one. And in my condensation reaction, I always get a little water molecule coming off. Now my water, as hopefully we all know, is made of an H2O. So my H2O I've highlighted there in a different color to show that this is the bit that's going to come off. And where this comes off, I'm going to link those other two parts together. And that's what's going to form the ester. So H2O, I'm going to remove that when they combine, they condense together, my condensation reaction. So H2O comes off, and I'm left with this empty bond here. And this empty bond wants to link up. So I'll link it up like that. Now, it looks a bit funny like that, this long bond here. So I'm going to redraw this of them closer together. And that'll be my ester formed, my condensation, condensing these two into one. So let's redraw that a little bit closer. So now my methanol part is a little bit closer and it's attached to the ethanoic acid part. So this was the methanol, and it linked to the ethanoic acid. But now it's not two different things anymore. It's one thing that's all connected. Now I have my ester formed. Of course, I've got my other product formed as well, the H2O that came off. So I form my H2O as my side product, and I've condensed methanol, ethanoic acid, into one ester. And the name of this ester is going to be based on these two parts. This is my ester link, the thing that links it all together, an O to a C double bond O. Wherever I see that, I know I have an ester link. So my ester link is linking these two halves. Sometimes if I've got a different colored pen, and if I don't, I imagine it in my head, is the split happening here between the O and the C double bond O. And that gives me my two different halves of my ester, my alcohol side and my acid side. So the alcohol side, well, we already knew was methanol, but if I didn't have that name, I would see the one carbon connected to the O. Yep, this is going to be my alcohol side, so this is the start of the name. One carbon is meth. So meth becomes methyl or methyl. Not too bothered about pronunciation, but methyl, methyl, as long as we got it right. So the one carbon, methyl. And then on this side, where I've caused this split between the O and the C double bond O, I can see this side here. Now this is my ethanoic acid side, two carbons. And a common mistake is people forget to count the one that's connected to the double bond O. But don't forget, there are two carbons here. So ethanoic acid, but it's not an acid anymore, it's a ester. So we change this name. We'll keep the F part, two carbons are still there. Ethan O8. All esters end in O-A-T-E, O8. So I have my ester, methyl ethanoate, and that was formed from the methanol and the ethanoic acid. So knowing the alcohol and the acid that put it together tells me the name of the ester. I'm going to draw another one now, and then I would like you to pause the video, guess the name of it, and then we'll reveal the name. So what would be the name of this ester? Now the first thing is to try and find that ester link. So our ester link is this part here in the middle, the C double bond O to the O. And like I said, between these two is where I imagine, and sometimes even just draw, a split between the two sides. And now I deliberately drew this the opposite way around than the previous ester we looked at. And that's okay, they can be upside down, left to right. They're all still esters, and they all still have to be named the same way, with the alcohol part coming first and the acid part coming second. So which side is the alcohol and which side is the acid? Well, when I've got this split here, and I'm looking at them in turn, I've got this one here, and then I've got this one here. Now, the one with the O is always going to be the alcohol side, and the one with the double bond O is always going to be the acid side. And that makes sense because carboxylic acids always have a double bond O, and my alcohols just have an OH, and it's missing that H, but I still mostly have an alcohol here. So this is my alcohol, this is my carboxylic acid. So I'm going to start with this side here. This side, my alcohol, and I see I have two carbons. Two carbons, meth, eth, eth. So it's an ethyl, is be the start of this name. So ethyl for this part here. And then the second part of this name has 1, 2, 3 carbons. 1, 2, 3 on this side here. Don't forget to count the one with a double bond O. So 3 carbons is meth, eth, prop. So prop is my third one. So this is an ethyl, prop, and O8. So all esters end in O-A-T-E, O8. Ethyl propanoate. So a good question would be, is if, say you were doing an exam and they said, name this ester, and we've just named this ester, then the next part of the question might say, what was it made from? What were the two ingredients that you needed to make an ethyl propanoate? And if we already know the name, then that's easy enough because we know it's the first part's from the alcohol, the second part is from the acid. So an ethyl will be an ethanol, so ethanol. And the second part of the name, propanoate, is going to be our propanoic acid, propanoic acid. And then if it was a particularly difficult assessment and they were being really nasty, there might be another part where they said, okay, now I want you to draw these two parts, the ethanol and the propanoic acid, if they give us the structure of the ester. So we've got the structure of the ester and we can draw these two parts because what I'm going to do is get my rubber, my eraser, and I'm going to break where I've got that split drawn in anyway. And when I split them apart, now I have my two different ingredients, the ethanol and the propanoic acid. And remember that I said it was a condensation reaction before to make my ester, condensing two into one, and I got that water molecule off. The opposite of a condensation is a hydrolysis. I add in water, hydro, and salicysis is splitting. So add in the water and it splits them apart. So I'm going to add in the water molecule to this to complete my acid and my alcohol. Now my alcohol just needs an H in here to become the full alcohol, ethanol. So the extra OH is going to go on this side for the acid. So H2O was added in, and that's how I get my two ingredients. From these two ingredients, the question could be asked a different way around. They could say, okay, we've got propanoic acid, we've got ethanol, what would be the ester, and draw the ester. So we know, okay, that's a condensation, condensing two into one. I take away the H2O, I fill in that gap, and I'd call it ethyl propanoate. So whether we're going backwards, a hydrolysis, or forwards is a condensation. So these two together, going this way, would be a condensation. Or if I have my ester going back into the acid and the alcohol, that would be a hydrolysis. So hydrolysis splits them apart and a condensation adds them together. Let's do a couple more examples. What would be the name of this ester? You can pause the video now and in a second I'll tell you the answer. Okay, so the name of this ester. As always, I want to try and find this ester link where the O and the C double bond O are connected together, and that's where I imagine that split taking place between my two parts. The next thing I need to do is work out which side is the alcohol and which side is the acid. Now, the alcohol is going to be this much longer section here because that's the one connected to the O along where that split is. So I've got 1, 2, 3, 4 carbons. So 4 carbons is meth, eth, prop, bute. So a butyl will be that first part here. And then the second part here just has one carbon. So one carbon, that can still happen. So meth and O8. Butyl methanoate. Again, a good question would be is, well, what would this be made of? Well, my butyl part would be a butanol, and my methanoate part would be from a methanoic acid. So it's always made from an alcohol and a carboxylic acid. They have a condensation reaction to combine together, and that's how I form my ester. Okay, what about this bigger ester now? What would be the name of this one? Again, I recommend you pause the video, have a go at trying to work it out yourself, and when you unpause, I'll tell you the answer. First thing is, when I'm working out the name of any ester, is to work out that split between the O and the C double bond O. This is my ester link, and this is what splits my two halves of the ester. The next thing I need to work out is which side is the alcohol and which side is the acid, because remember it could be either way. It's not red left to right or right to left. So it's just whichever side the O is connected to is the side that is going to be the alcohol. So the O is connected to this side here, so this long chain here, 1, 2, 3, 4, 5, 6 carbons. So 6 carbons, meth, eth, prop, bute, pent, hex. So a hex is going to be the start of this name, hexyl. So a hexyl for my 6 carbons. Now the second part, this half here with the double bond O, this is the bit that comes from the acid, and it's only got 3 carbons, so meth, eth, prop. 3 is prop, so prop, Hexyl propanoate would be the name of this ester here. And what would it be made of? Well, you can make it from the hexyl, would become from the alcohol hexanol, and my propanoate comes from propanoic acid. What type of reaction joins them? That's a condensation reaction, condensing two things into one. And I would have also got an H2O formed from this reaction. Esters. Esters are used for their sweet smells most of the time, sort of artificial flavorings and sweets and washing up liquid. Always has a strong ester kind of smell. And that's it. If you have any more questions about esters, then leave them in the comments section below, and I'll do my best to try and answer them all. And if you've enjoyed this video, you want me to make more videos, then suggest what kind of videos you'd like in the comments. Give this a like and a subscribe, and good luck with all your studies. Bye.